Okay, so these three problems, A, B, and C. For A, the estimate of integral from 0 to 100 g of t dt is equal to 4 subintervals. So I like to just draw the blanks first, because then we just have to fill in the blanks. So we want to use a left Riemann sum. First of all, I want to look at the width of the rectangle. So the first one looks like 40. This next one here looks like 30. This one here looks like 20. And this one here is 10. Is that what you got for that one? Mm-hmm. And then really we just have to pick the correct one here. So the rectangle here, the left one is going to be, so you have to choose. Your left one is going to be that one here. So we get 150, and we can just write these out. The next one's 180, then 184, and 195, 195. And then that would be 184, right? And then for B, it's the same thing except what?
It's the right one.
Yeah, g of t dt. So is the width of the rectangles exactly the same? Or yeah.
Yeah.
So we have 40, 30, excuse me. We have 40, 30, 20, 10. And then we have here is we use the right one here, 180, 195, 184, 172. I hope you can see, I guess it's hard because we're increasing here and decreasing here. So it's hard to tell exactly what's your better value. Now you have the trapezoidal sum, 0 to 100, g of t dt is equal to blank plus blank plus blank plus blank. So all these, we're dividing all these by 2, and we have the height of the trapezoid is the same as the width of the rectangles here. And I'm going to have trouble coming up with room for this here, but we have these two that's your base 1, base 2, so 150 plus 180. I know one way you can get around it. If you can just add those in your head, right?
That's 300.
That's 330. I have trouble adding these. 375. That's these two add together. Now here,
379.
yeah, because that's going to be a minus 16 and a minus 15 off of, or minus 5. So that's minus 16 and minus 5, which would be minus 21. So it's going to be 400 minus 21, or 379. The last one here is going to be 356. Okay, but you don't even have to add those in your head or anything. It's still correct, okay? And the next one we have here is this 3. So I want you to do 3. We have find trapezoidal rule estimates for this. Can you read on your graphs okay for number 3?
Mm-hmm.
Good enough, yeah.
Yeah, you can see, I hope. And they give you they give you an n equals 3 and an n equals 6 for this. One thing you can do in a situation like this is you could actually, if it makes your life easier, you could convert to a table first. It might make your life easier. I don't know. Mike.
Oh,
Wait,
nuts.
what is the question asking?
Okay, so we have x, f of x, so 1 through 7. So 1, 2, 3, 4, 5, 6, 7. Then you just kind of look at the height there. That looks like that's going to be 1, 2, 4, 5, 6. And then that's going to be 4 point something. Well, I'll call it 5 just to make life. So 5, 4.
Oh, I did the one with n equals 6 first, dang it. Oh.
And then for n equals 3, so estimate, so part A, estimate of 1 to 7 f of x dx equals blank plus blank plus blank. So we have 2, 2, 2. So looks like we have a width of 2. They're all going to be widths of 2, aren't they? And then you have base 1 plus base 2. So 1 and 4, 1 plus 4. This next one here, 4 plus 6. And the last one, 6 plus 4. So that's part A. And what is part B? Well, it's just the same sort of thing, but for each interval. So just 1, 2, 3, 4, 5, 6, plus 4, plus 5, plus 6. So it's the same sort of thing here. This time your width of each trapezoid, height of each trapezoid is going to be 1. 1. That's going to be a plus sign here. 1 and 1. So you just take these and add them together. 1 plus 2. 2 plus 4. 4 plus 5. 5 plus 6. 6 plus 5. 6 plus 4. And there you have it. Let's see. This is not hard, is it?
No.
To me, the hardest part is just like figuring out, do you think it helps to convert to a table first, maybe? I don't know.
Yeah.
I just thought that was a good
I
idea.
did it.
You just did it without that? It just helps me, just for me, it makes me, for me, keep things a little more organized, that's
I
all.
just squinted really hard at the graph the whole
You
time.
squinted at the graph, yeah, that is. And the thing about it is that it's not really super legible up here, but it's even worse on your paper, isn't it? Yeah. Okay, here's another one right here. Use it to find a midpoint approximation with 4 subdivisions. Can you read this one okay?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, second.
There's 1, 2, 3, and 4.
Okay, yeah. I thought that looked halfway like a 5. And that's oxygen, yeah. Yeah, so go ahead and finish 4 and 5 today. And I think it'll be good after you finish 4 and 5.